Our speakers for today are Raghu Tyagarajan, Director, Partner Product Management at Hortonworks, Kimberly Palko, Principal Product Manager, and Kenny Peoples, Principal Technical Marketing Manager, both from Red Hat. At this point, I'm going to turn it over to our first speaker, Raghu. Let's get started.
Thank you, Cecile. Good morning and welcome, everyone. My name is Raghu Tyagarajan, and as part of my role in Partner Product Management, I work very closely with our strategic partners to create reference architectures that really help optimize the delivery of the Hortonworks data platform. And I'm very pleased to join Kim and Kenny today from Red Hat, since we're very close partners with Red Hat. And we've been working very closely on tying together the Red Hat data virtualization platform with the Hortonworks data platform to extend the capabilities of the Hadoop experience for our customers. So with that, let me introduce Kim and Kenny, if you'd like to say a couple of words about yourselves.
Okay. Hi. Thanks, Raghu. So I'm Kimberly Palko. I'm a Principal Product Manager here at Red Hat JBoss Middleware. I've had over 15 years experience in the distributed computing and integration space. And right now at Red Hat, I'm the product manager for our JBoss data virtualization product that we'll be talking a lot about today, as well as the product manager for our big data initiative across the middleware portfolio. So I'm very happy to be here. Love working with Hortonworks. And I'm here with Kenny Peoples. Kenny, would you like to introduce yourself?
Yes, thank you, Kim. So I'm Kenny Peoples. I'm the JBoss Technology Evangelist for data virtualization, as well as use ServiceWorks for Red Hat. I work on blogs, white papers, videos, demos, anything to get material out around the integration products, data virtualization, and use ServiceWorks. So I'm glad to be here today showing the two use cases that we have along with the collateral so that you can run these demos on your own. So thank you, and I'll turn it back over to Raghu.
Thanks, Kim and Kenny. So let's get started then. The first part of this webinar series, John Kreiser from Hortonworks laid out the context behind the new kinds of data that are emerging in the enterprise. And what this is doing is introducing new structured and unstructured data types like clickstream and machine sensor, log data, etc. And this is data that's not traditionally been managed, right? It's data that grows at exponential rates compared to some of the structured data we've dealt with in the past. And the sheer volume of the growth of this data is expected to grow about 20x between 2013 and 2020, right? And what this is doing is it's putting all kinds of pressure on traditional data architectures. And so obviously enterprises need a new way to cope with this data. The options are pretty simple. One is do nothing about it and lose valuable insight into the richness of the data that you are collecting about both your customers and your enterprise, right? Or the other is to extend your data architecture to what we at Hortonworks call the modern data architecture. And so let's transition over to the modern data architecture slide. All right, so very recently at Hortonworks, in April of this year, we released HDP, the Hortonworks Data Platform 2.1, right? And if you take a step back from the kind of the way one thinks about Hadoop, it was really traditionally the Hadoop distributed file system for extreme scale of storing data, right? And the other, and in an inexpensive way. And the other thing that it provided was a MapReduce metaphor for being able to crunch that data at large scale. Now, these traditional jobs were, of course, very batch-oriented, and they were very programming intensive as well, right? So we at Hortonworks see that as we transition Hadoop into the mainstream enterprise, there are a set of capabilities that go above and beyond this kind of traditional notion of Hadoop. And we've been working very hard at extending it to support some of these enterprise qualities as we think of them. So if you look at this figure that shows the Hortonworks Data Platform 2.1, at the heart of it is what we think of as core Hadoop, which is the data management piece, and that's the Hadoop distributed file system. And along with that is a set of data management capabilities that are really powered by some key innovations we've made here at Hortonworks called Yarn and Tez that are part of the Apache Hadoop community now. And these infrastructure capabilities were necessary as we set to move past the traditional MapReduce notion and the programmatic paradigm of Hadoop to be able to support a rich variety of engines that don't just do MapReduce and batch workloads, but also add things like Hive for SQL access, right? So that a number of BI tools can actually get access to this data using their traditional SQL metaphor, as well as enable workloads that are much more real-time in nature, such as Storm for real-time stream processing, right? We've seen that as we've extended the engines that allow different varieties of data access to the same pool of data, a couple of key requirements are pretty obvious. One is, in terms of SQL, we had to step above and beyond the traditional MapReduce metaphor. And so the Tez engine, which we've released at Hortonworks, is really intended to speed up the ability of SQL to provide interactive SQL capabilities for Hive. And the other part of it is Yarn, which allows all of these different varying workloads to coexist on a single cluster without treading over each other's resources. So that's really kind of the fundamental infrastructure that we think of at Hortonworks when we think about providing data access to everybody. Now, if you step beyond this functional interface to the system, there are a number of enterprise capabilities that we've added, starting from the left around governance and integration. So let me talk a little bit about that. If you look a little bit more detailed on the slide, you'll see on the left block, you'll see Falcon. And Falcon is basically provides governance by way of coordination of data pipelines for ETL processes, lifecycle management, and data replication policies, etc. So that's really critical as you think about multi-data center workloads, synchronization, replication, etc., and management, lineage, auditing, a lot of data governance capabilities in there. Next up is something called Scoop, and Scoop is basically, again, an Apache open source project, which allows the ingestion of data, bulk data, from between traditional RDBMSs and Hadoop. And finally, I'd like to talk a little bit about Flume, which is yet another integration alternative, which allows us to ingest large unstructured and semi-structured data, like log data, into the Hadoop file system. And we'll touch on why these are key later down the presentation as well. In terms of security, so the Hortonworks Data Platform focuses on a number of capabilities such as authentication, authorization, etc., which are complemented very well with our partners from the Red Hat Data Virtualization team. And the things we focus on are really around authentication to the Hadoop cluster, as well as a unified authorization mechanism across all of these data access engines, so that you don't have to think about each of these as individual Apache projects, but provide a unified access mechanism, as well as provide auditing across all of these engines. So that's our focus on security. And finally, on the operational front, Apache Embari is kind of our key initiative that provides unified monitoring, management, and provisioning for this distributed and diverse Hortonworks Data Platform. So that's the Hortonworks Data Platform in its entirety, and we continue to innovate on a number of fronts here. Let me move over to the next slide and transitioning over. One of the key things as we look at how Hortonworks Data Platform fits into the enterprise is obviously we don't exist alone in your enterprise data architecture. And part of the modern data architecture is really being able to leverage and extend your existing investments in a number of systems. So let's start with the data systems that you already have in place, such as traditional relational SQL systems, Teradata, SQL Server, etc. And we integrate and extend the capabilities with things like ETL offlining to the Hadoop system. With BI tools as well, through Hive especially, we have enabled integration to a number of discovery tools. And as you'll see in this presentation, with data virtualization, we take that up a notch even further. And we've obviously focused on integration with operational tools. So if you already got your enterprise systems in place with partners such as Microsoft or Teradata Viewpoint, Apache and Bari provides a good integration point as well, so that you have unified manageability. Okay, so moving on, let's kind of start to dig into one of the scenarios that I wanted to illustrate where these products actually provide some joint value to our customer base. So if you think about the, and let me start out by kind of showing you the right side of this figure. And the right side of this figure basically illustrates that in a traditional enterprise, through data virtualization, JBoss data virtualization, there are a number of SQL interfaces and number of data sources that you want to leverage in combination. And the reason for this is pretty straightforward. You have operational data coming through your traditional database servers, right? And then through the Hortonworks data platform, you have this richer modern data that we are both able to extract out of their source systems and refine in a way that it can be actually SQL consumed, right? And so what we're trying to illustrate here is the ability to be able to extend and leverage your existing investments in a SQL database technology, but which by itself can't provide necessarily anything other than the operational view, and extend that to get some of this rich data so that now you can start to look at customer data in a much more interesting way to be able to look at some of the semi-structured information you're picking up about this customer. So the obvious example over here is one of the examples is sentiment data, right? And as you'll see in the demo later, what we're trying to do is really join the sentiment data with sales data to provide some interesting insights that were not previously not able to answer. So in this particular case, let's say the sentiment data is coming in through Twitter on the left. Now, I talked about Flume previously. So Flume is used here to ingest this Twitter stream and into HDFS, right? So that's the extraction element of the Hortonworks data platform and allows us to pull that sentiment data in. Now, remember that this Twitter stream, the data is still in a semi-structured, unstructured kind of mode. There's some text data that by itself doesn't add very much value. And so what we do through Hive is a couple of things that are really interesting. So we want to make this data structurable so that it can be now accessed through traditional BI and visualization tools and surfaced by the JBoss data word to be able to tie together with other structured data. So that's really what we're trying to do with Hive over here, right? And further, once we've structured it, we actually want to refine that data so that we can actually extract some numerical or quantitative values out of that text stream that's flowing in. So let's take a look at how that happens here in this next slide. And give me just one moment there. So as we start to look at this next slide, what you'll see, and I apologize for the mouse movement here. Okay, there, we got control. So we're missing some of the animation on this slide. Okay, so I was trying to actually illustrate a couple of key points, and what I'm trying to show in this slide is actually at the back is this kind of raw stream of data that's coming in that we're ingesting through Flume, right? And this raw stream of data is basically just a number of tweets, if you can imagine it. And what we're trying to do is create a Hive DDL to be able to structure that data and extract it into tabular format, right, in a way that actually can be queried. So we do that using Hive and create the structure around the raw data. In addition, what Hive is doing is it's actually extracting and it has a dictionary table. And what we've done is created a dictionary table that allows you to map sentiment terms to their associated values. So at the end of the day, what we got is a table that not only transforms from the input raw unstructured data, but actually moves it into numeric values associated with that sentiment. And now, from a user perspective, that becomes really valuable because you're able to join that kind of analysis that's happened and join it up with the sales data to make some interesting correlations between the sentiment of that product offering and the sales, which will be highlighted a little bit more as Kim and Kenny walk through their presentation. So where we're moving on to is now into Hive, which is kind of a key component of how all of this is enabled, right? And so with Hive, as you can see, one of the key things behind Hive was it was based on traditional MapReduce paradigm, which meant that Hive queries would take a while, right? And some of the key investments we've made on the Hortonworks side is really around speed, scale, and SQL, right? And those three things have actually become key in being able to work with partners such as JBoss, where these queries are now much more interactive in nature, and that allows you to unlock not just do batch-oriented SQL processing, but do much more exploratory analysis, right? So you can start to take your visualization tool and start to ask what-if questions. The other thing is the amount of data that you can ingest, especially with these rich unstructured data types. You actually made the transition from terabytes to petabytes of scale with SQL. And finally, the number of constructs, and this continues to be an area, key initiative area for us, is adding really rich SQL constructs to enable these BI tools and end users to write queries in a familiar metaphor. So let's take a look at one more example now of how this data can actually be supported through data virtualization. So in this picture, what you see is an interesting scenario. It's really a multi-data center scenario, and obviously in Hadoop, customers use multi-data centers for multiple reasons, right? One of them is disaster recovery, where you're using Falcon to be able to synchronize and replicate data. The other is for archival purposes, where you're able to actually push some data to a backup data center for disaster recovery reasons. And all of those are good reasons. What we find also is there's another reason that many customers are looking at multi-data center scenarios. And in this example, what I'm trying to illustrate is a retail product supplier, and they have geographically distinct clusters for regulatory reasons. So obviously in the EU and especially European countries, there are some very strict regulations on where customer data can be resident and what geographic boundaries it can span. And for this reason, an enterprise can choose to actually split up their customer data between multiple data centers for privacy reasons, right? And so what happens is on the left side, this retailer is actually getting sales data and customer data, and the sales data table is really their fact table, and customer data has some dimensions, etc. And so what they're trying to do is they get frequent updates of all their sales data that's being ingested through various techniques, especially through the extract, transform, load capabilities using Scoop and Flume. So we bring that in to HDFS, and we do the same thing that I talked about previously, where we refine this data through Hive and cleanse it. And then, because of Hive's speed that we talked about and the interactive query capabilities we talked about in the previous slide, is now consumable through JBoss data virtualization. As we talk about some of the capabilities of JBoss data virtualization, this ability to be able to screen the data to make sure that end users don't necessarily see the data, are not allowed to see data that's not in their visibility zone. So the kind of data that we're talking about here is something like customer data. And as you can see in this table, there are a fairly large number of fields that you don't actually want people, a large number of confidentiality fields that you don't want the average observer or user of the data platform to be able to see. So things that are like address, first name, birth date, all of this is fairly confidential information, and we want to make sure that's protected. So the combination of the Hortonworks data platform And JBoss data virtualization actually enables some of these scenarios that we've talked about. And with that, let me hand it off now to Kim, and I think Kim will take us through really the detail on the Red Hat side about how this is enabled. Over to you, Kim.
Okay, hi, thank you, Raghu. So let me move through the slides here. Okay, Cecile, I don't know if you can help with this. I'm wanting to move through the slides. Okay, here we go. All right, so let me just dive right in. I think before I get started on JBoss data virtualization, I would first give just a quick overview on our partnership with Hortonworks. As I said at the beginning, we love working with Hortonworks. They share the same commitment and understanding of open source that we do here at Red Hat. And Kenny and I are going to be talking mostly about the integration with the JBoss data virtualization product today. But I did want to take this opportunity to mention that we have a lot of activity going on with Hortonworks here at Red Hat, including other products in the JBoss middleware portfolio, like our BRMS rules product and integration with our JBoss data grid. We also have a partnership around our integration with Red Hat Storage that brings secure, resilient storage pools to Hadoop, as well as integration with Linux on OpenStack to simplify deployment of Hadoop on OpenStack, and integration with RHEL and OpenJDK for multiple different deployment scenarios. So before we go into more detail, I wanted to give kind of a bit of an overview of JBoss data virtualization and what the product does. First of all, you can kind of think about it like a virtual machine for data. And what it allows you to do is to be able to connect to multiple different kinds of diverse data sources. So not just your traditional relational data sources and data warehouses, but also the newer NoSQL data sources like Hortonworks Hadoop Data Platform, as well as files and web services or RESTful services, and also even cloud services. So what you can do is connect to those data sources and then compose a model and what we call a virtual database. And so the virtual database is actually a view of the data across all these sources, but it appears to the consuming app as though it is, tables in a single database. And another important point here is that it does this without moving or copying any of the data. So, one approach that people take sometimes when they want to get a report that combines multiple different data sources is to move all the data into one data source. And of course, this is resource intensive, and it also, adds for copies of the data, which adds complexity and security risks as well as data quality risks. And what a data virtualization allows you to do is to leave all the data in place so there's a single version of the truth, and then be able to query and consume the data from the virtual database. And you can consume it in multiple different ways. You can consume it through any BI tool that's ODBC, JDBC compliant. It's all the consuming is through open standards, which Red Hat always supports. Also SOA web services, RESTful services, including the new OData standard, which is getting a lot of traction and interest, and as well as any of your Java applications. So how do we do this in terms of integrating with Hadoop? Well, you start with your application side, and what we do is that we can take the rich SQL dialect of BI tools or any of the consumers, and the data virtualization server will actually translate that rich SQL dialect into Hive QL. And then from there, Hive translates that to MapReduce, and the MapReduce runs the job on Hadoop. And this is a big benefit that people appreciate. You can use any analytics or reporting tool, and you can use it in a full-featured way. I know a lot of people who are getting started with their big data projects, it's really important to them to be able to use the tools and not that they already have in-house without having to go get new training or actually hire in new skill sets. And so this capability with data virtualization allows you to use the tools that you already have in-house. And we certified originally with Hortonworks data platform in our 6.0 release earlier this year, and we are constantly updating that certification to bring the latest updates that Hortonworks provides on their side to their technology. So I did want to talk a little bit more on the consuming side and the benefits that are seen there. So we talked about being able to consume from any of the tools that you have in-house. We've found that although it might be a goal for organizations to have just one BI tool, it tends to be that, different departments or different people have their own preferences. And that's no problem with data virtualization. We support, all the BI tools, ODBC, JDBC compliant, and, with their full features. We also can allow different logical views of the data. So there are multiple different ways you can architect your virtual databases, and we allow for different views of the data so that each of the users can get their own really logical view of the data, filtered, for their needs. I also wanted to talk for a moment about caching, because this is a performance enhancement capability that a lot of people that are dealing with big data, with huge data sets, really appreciate. And we have a couple of ways to cache your data, and I'll talk about both of them here before handing over to Kenny to go through a demo. One is to be able to materialize a virtual view of the data. So in this case, you might have different applications with different queries, and what we do is we query the original data source and then create a cached view of that data. And then any query that comes in can go against that cached view. So it's the same view for multiple different queries. This cache can be refreshed either automatically through a variety of ways. We have, admin scripting, even an API where we provide the hooks for you to be able to do that through your code. We provide scheduling, or you can manually do it through our admin tools. And we also support different databases. Any of the long list of data sources that we provide translators for out of the box can be used as a cache repository. Now, another way that we cache data for faster performance is what we call result set caching. And this is a little bit different than the materialized view in the sense that this is for the same query that's being asked over and over again. And the first time the query hits the data source, it goes all the way to the data source. So in this case, it would be Hortonworks Hadoop, and returns the result set, which can sometimes be very large. Then if you choose result set caching, which is very easy as a checkbox in our tooling, then subsequent queries from then on will hit that result set cache, and you can have unique result set caches for different queries. And so I think, this is another thing. We did demo this. We have demoed this before with Hortonworks, and it is a performance enhancement that a lot of people with very large data sets really appreciate about using the combination of data virtualization with Hadoop. And so with that, I will hand it over to Kenny Peoples for the demo.
Awesome. Thanks, Kim. So we do have a question. How is JBoss data virtualization priced? And Kim, I'll turn that one over to you if you want to answer in the Q&A blog, or when I turn it back over to you on the next section, if you wanted to address that, I'll go ahead and move on to the demo. So this is a demonstration combining the sentiment data from Hadoop with data from a traditional relational source, which is MySQL. All right, so for use case one, the demo that we're going to be going over first, our objective, we want to determine if sentiment data, which are from tweets from the first week of the Iron Man 3 movie, is a predictor of sales. So the problem space is we cannot utilize social data and sentiment analysis with sales management systems because they're in different silos. So the solution is to leverage JBoss data virtualization to create this unified view of the sentiment analysis data with ticket and merchandise sales data from MySQL into a single view of that data. So when we look at the diagram, we have the source one, which is the Twitter data, including sentiment data that we access through Hive, which is on Hadoop. And the second source is the MySQL relational data that includes the ticket and merchandise sales. So we connect to those two data sources. We compose a unified view in our designer, and then we deploy that to data virtualization, and then we can consume that through different business intelligence tools, different tools such as Excel Power View and data virtualization dashboard that is included with data virtualization. And so the architecture, as I mentioned, we have traditional repositories, a relational database in MySQL, and we have Hadoop with the sentiment data, and we're using the unified view through data virtualization so that applications can use that data. And the resources for both of these use cases that we will be covering, we have the how-to guide, we have the tutorial out on Hortonworks, we have videos, and we also have source code. So you can go out to github.com under data virtualization by example, and you'll see the 3 Hortonworks use cases, as well as the data virtualization workshop. There's also videos out on Vimeo, and one of those are included in the tutorial.
Let's start with our data virtualization by example organization out on GitHub. Here we have our Hortonworks use cases loaded, as well as the data virtualization workshop. So you can go and take a look at Hortonworks use case 1, all the supporting files and documentation how-to guide. I also have it out on speakerdeck.com/kpeoples with the Hortonworks and Red Hat proof of technology slide deck. First, you want to install the Hortonworks sandbox. I'm using the sandbox for VirtualBox in version 2.1, and here you can see that there's different VMs available, and so you're going to want to download that, and then we will install or load the Tweets BI table, which includes the sentiment data and our Twitter feeds. So what I'm showing here is the UI for the sandbox. In here we can go in and look at the Tweets BI table, and this should contain our sentiment data for our individual tweets. The tweets BI table, as you see here, is in the default database, and so I chose that option, import data, and pulled in the data from a CSV. And just to take a quick look at the data, it has individual tweets in the tweets BI table by country with a sentiment value. And so in our unified view, we're going to average the sentiment by country when we build the view so that we can analyze the data. And here you'll also want to install JBoss Data Virtualization. It is free for development use, so you can grab the jar installer and install the product, and then you'll be able to deploy the virtual database that we'll go over in just a minute. And so next we'll go through the JBoss Management Console, and you can see here that we have added our data sources for our sandboxes here, connecting to the sandbox that contains the tweets BI, the sentiment data. And we also, of course, have the data source for MySQL. And then under the TID virtual database, we've deployed our virtual databases. And with use case 1, our Hive test VDB is going to have our views, including our sales sentiment view, our unified view, and here you can look at the data definition. And you'll notice that we're averaging that sentiment view or sentiment value per country. And so this is our VDB that we created in JBoss Developer Studio and deployed to data virtualization. So next, let's go over to our JBoss Developer Studio, show you a little bit about how we built this and then deployed to the data virtualization server. If you'll notice, we have our different models. I have one for Hive so that we can access the sentiment data on Hadoop through Hive. There's our tweets BI table. And then our MySQL sales data, which is in MySQL, that contains the merchandise sales, the tickets sold, ticket revenue. And here we've created our sales sentiment country. So we've taken those two sources. We have our transformation, which you see here, averaging that sentiment data by country. And we're combining that into that single view, the sales sentiment country. So we can access that view in the virtual database. It pulls back data from both sources, and it materializes that view as well so that it's cached quicker after the first time. For use case 1, I'm going to start with Squirrel SQL Client, and I'm showing here how we can use the Hive driver and point to the Hortonworks data platform sandbox to test the tweets BI table that we loaded into the sandbox. You can find all the instructions for doing the actual loading on GitHub. Next, I want to show real quick that we're accessing our MySQL data over in MySQL Server. And this is all the sales data. The Hortonworks data or the Hadoop data contains the sentiment data with the Twitter feeds, the tweets, and this contains the merchandise and sales data. Now with the unified view, we're going to use the TIA driver to access the virtual database that should pull in data from both MySQL and Hadoop. So this is the sales sentiment country table that we just pulled in, you'll notice average sentiment by country. So we did an average sentiment on all those tweets that are in Hadoop. And so within the data virtualization dashboard, we're going to set up an external connection to connect to the virtual database. You'll notice the green on the red light there. And so we're accessing the Hive test virtual database with the TID driver, which is the community project data virtualization is based on. And we're going to have a data provider with the sales sentiment country. I misspelled there, but we're going to select from the Hive test VDB, from the sales union view, from the sales sentiment country table. And here with the data provider, you can modify some of the properties for each of those columns. So what we are going to switch to here is the sales sentiment sales workspace. We've added a page, added a panel. Within that panel, we're displaying all the data here: country, population, number, tickets sold, ticket sales, merchandise sales, and average sentiment. And if I go into the panel settings, see I have a data table that's used in that external connection and data provider to pull that data. So data virtualization gives us the ability to quickly see the data through the virtual database and test it. And next we'll move on to Microsoft Excel. With data virtualization dashboard, we were using the JDBC driver. Over with Microsoft Excel, we're going to use the ODBC driver with the access to the virtual database, and it's based on the Postgres SQL driver. And so once we set up the ODBC driver with its settings, then we can go over into Microsoft Excel, and here you see the Power View. But first let's go over to the worksheet and take a look. You'll notice I created a column separate that has a sales goal, but all the other columns are coming in from data virtualization with the virtual database from the unified view. And we created the Power View here with the map for the number of tickets sold by size and the sales goal by color. So you can see the size and color there, and I can click on a goal which will pull up, kind of highlight those with that sales goal in the country. So you can go by those that didn't meet it, 0, met it, 1, did not, exceeded goals with a 2. So very powerful with Microsoft Excel, being able to analyze that data that we've created a unified view with data virtualization.
Okay, thank you, Kenny, and thanks for that demo. So I am going to go very quickly. I want to leave time for Kenny to do the second demo. And I can see that Ramesh Reddy, he's a project lead for TID, which is the upstream project for a data virtualization product, is answering questions, which is great because in the chat dialogue, because I don't know how much time we're going to have to get through those at the end here, but we will try to get to them or defer them, answer them offline. So I did, before Kenny goes into the next demo, wanted to talk a little bit about the security features of data virtualization. The big point here that a lot of people really appreciate is that data virtualization allows a centralized layer where you can apply security policy consistently across multiple different data sources. So let's say, for example, all you're using is relational databases or data warehouses that have mature security capabilities, then that's probably all you need. But when you start combining with data sources, some of these very new data sources that do not have the same security features, then what data virtualization allows you to do is to have a common security policy to assure that you have the same level of security no matter what data source you're connecting to. And we have multiple features to be able to help in that regard. One is user-based access control. It allows you to work with your user hierarchy, integrates with external authentication mechanisms like Kerberos or LDAP. I have a complete list on the next slide. And then we get that external authentication, and then you can assign users and groups within your virtual database, either a one-to-one mapping to your external authentication, or you can create your own new mapping within data virtualization. So the authentication mechanisms we integrate with are numerous and various. We have Kerberos and new in the upcoming release coming out early next year, in addition to from the client to the virtual database, which we've had for some time. We will also have Kerberos authentication all the way to the data source. We'll also support login modules like LDAP, any JAS-based security, WS username token for web services standards, as well as HTTP basic authentication for REST and SOAP-based services, and SAML authentication for web client applications. In addition, we have a centralized audit logging capability. So once you have your user roles defined, then you can have a central log to keep track of everybody who has accessed the data and when. And we recently introduced this dashboard that people are really loving to have in the product in our most recent version. In 6.1, we're adding the capability for you to see the audit log out of box so that you can monitor security across all of the virtual databases that you have. And we also have row and column masking, which Kenny is going to demo in some more detail. Allows you to be able to mask out rows based on any trigger. I think the one Raghu talked about and Kenny will demo is based off a geographic marker, which is very common to use. And we also have column masking. So this is, showed here very easily. You can just null out values, or I've also given an example on how you can use a SQL statement to say it's very close to tokenization, where you can replace, for example, the social security number or credit card number, all but the last 4 digits. So a summary of the security capabilities. We have a lot of authentication, authorization, centralized administration, auditing, centralized auditing and logging, as well as protection through row and column masking, as well as SSL encryption for ODBC and JDBC. And again, this is a common centralized policy that can be enforced across multiple data sources at the logical virtual database level. And so with that, I'll turn it back over to Kenny for the demo.
Awesome. Thanks, Kim. Okay, so let's go through what use case 2 demo should cover. And I noticed looking at some of the responses that maximizing the screen made it blurry to some. So what we'll do is I'll go through the overview and go through the demo, but I'll keep it at the regular resolution instead of maximizing it. And if you have problems seeing it, then I did send out in the chat the link to the GitHub repo, and you can go under each use case, and there's a video directory so that you can see the videos, and hopefully it will not be blurry when you go download them and take a look. So let's go ahead and move through this real quick. We're running out of time. So use case 2, our overview, with the objective we want to secure data according to role for both row-level security and column masking. So the problem space, we can't hide region data from region-specific users or mask some of the sensitive data. Well, the solution is to leverage JBoss data virtualization to provide the row-level security and the masking of columns, which can be done with the virtual database when it's created. So as we go to the right side, the diagram, in this case, we have a U.S. region sandbox with data as one source and the EU region data as a second source. And so we connect to those two. We compose the virtual database with the appropriate row-level security and masking, and then we can utilize that data in whatever tool that we want, whether it's data virtualization dashboard, the Squirrel client, whatever. And so, on to the next. And then with the architecture, as I mentioned, we have two Hortonworks data platform sandboxes that represent a region, and then we can access those through our virtual database for data virtualization through our application. And as I mentioned before, we have the how-to guide so that you can run these demos yourself. There will be a tutorial out on Hortonworks for use case 2. We have the videos, and like I say, we have the source code and the supporting files. So let's go ahead and see if we can add the, so I feel like I can't share the videos, I guess, because I'm, yeah, there you go, okay.
So with use case 2, we have our two sandboxes, as I mentioned. And we have the US sandbox, the EU sandbox, and we have the customer and customer address data loaded into both of those sandboxes. And so within our virtual database, we're going to add the row level security and column masking. So here you can see I've taken the sandbox, the virtual machine, and loaded two different ones into VirtualBox. Here is our first one, our EU, European Union sandbox that we've loaded data into. I don't have Ambari running due to memory constraints, but everything's gonna work okay. So within our default database, we created those tables, customer and customer address, from the data, which is also out on GitHub. So here you see all the different components of the Hortonworks sandbox, Hortonworks data platform. And this one that I'm showing now is our US sandbox. So within our tables, we're going to use the customer table here, and that should have the birth date, should have the day, month, year, and country for birth date. And what we're going to do is mask those out. But I wanted to show how the data was set up so that you can see how we're going to do implement the row level security and the masking of the columns. So just take a minute to pull up the those tables. So again, I grabbed the HDP 2.1 sandbox, downloaded it, and created two sandboxes for US and European Union. And I also downloaded data virtualization, used the jar installer, which you can get from jboss.org, so I can install my virtual database. So here I wanted to show that our country is in the customer address table, and that's what we're going to key off on for our sample for showing row level security. And this is, again, our customer address table. And so within our customer table, we have our birth date that I mentioned, day, month, year, and our country. And we're going to null those out if it is a EU user, US user, but of course see them for a admin user. So I wanted to quickly show some of the setup within our virtual database, our JBoss Developer Studio. So here we have our EU source, our US source, and our unified view. Of course, I did a little misspelling there. I have to correct that. So from those two, you can see the sources. This is the example of the customer. We're just going to grab all the data for that view. And within our virtual database, I created two just to keep it simple. We're going to, within the one virtual database, we have our admin user and our regular user, those roles, and we're not going to have any masking there. So you'll notice no masking. Then when we look at the mass birth date data role, we have the EU access and US access, which are mapped to the roles in the TID security files, the data virtualization role files. You'll notice we're going to mask the country, day, month, and year, and I do have all those masked out as null. And so with the row level security, I created a different virtual database, like I said, to keep it simple. And so for the admin user, we have super user all data. But with our EU row level security data role, or our US row level security data role, we have the conditions. Again, this is the super user. Admin user role is going to see everything, no conditions or masking. But like I say, for EU or US data role with the map role names US access or EU access, we have a condition for the EU access that the country's not equal to United States, and for US role, it's equal to United States. And so if we switch over to the management console, just to show that we have our EU data source and our US data source, that we're accessing the sandboxes, the two sandboxes that we set up, and you'll see the IPs match what I was looking at on the sandbox UI. And then over on virtual databases, you'll notice we have our two virtual databases that I mentioned, and you can look at the data definitions for those. You can also look at the security, the data roles that are set up for those, whether looking down at the row level security data roles, and we can also look over at on the other virtual database for, of course, the admin access and mass birth date. Awesome. So let's take a look at the data. Test the virtual databases. Look at the sandboxes. Here's the European Union Hortonworks data platform, and we're using the Hive driver, so we can view customer address in that sandbox. Then when we look at the Hortonworks data platform for the US region through the Hive driver, we'll be able to see all the US region data. So we have those two sandboxes. Now we created the two virtual databases, one to show masking of the birth date. Using the TID driver here in Squirrel Client, we can access these virtual databases. And the second one is the row level security with the addresses that has the country, and we're going to use the row level security there depending on the user that's signed on, of course, and their role. And so, as you'll notice with both of our Hortonworks data platforms, it's for EU or US. Here we're looking at customer and customer address for those two sandboxes. So you can see the country field is there for customer address for both. And so if we switch over to, say, the unified views for the first test case, the customer field, the customer table with the birth dates, they're going to be nulled out because we have signed on with the European Union user and European user access. So the null values are going to be in for all the birth data information. This is when accessing the unified view virtual database to show the masking. And if we look at the unified view masking and unified view row level security as user, the admin user, we're going to see all the data for both. So let me quickly describe the test cases as we're looking at all of this setup here. The first test case, of course, with the customer field with the birth date. If it's the admin user, they see everything. If it's EU user or US user, the birth date is nulled out. They cannot see the birth date information. And then if we go to the customer addresses as user, of course we see, or the admin user, we see everything. Here, if we look at the row level security signed on as European Union user with the European Union access, only get the European Union rows for that region. So if we sign on as US user, they're only going to see the US region data. So now you've seen everything through Squirrel. And
so just in closing, want to kind of reiterate the benefits of JBoss data virtualization with Hortonworks Data Platform 2.1. It allows you to combine the new data Raghu talked about in Hadoop with data in traditional sources without moving or copying, as well as giving access to a variety of consuming tools, including all the BI tools you already have in-house, not requiring any additional training or in new tools or technologies. We also provide a variety of caching mechanisms for faster access to data, as well as the ability to provide consistent security policy across multiple data sources. So with that, Cecile, I'll pass it over to you. I'm not sure how many open questions we still have. We've been answering them in the chat box, or how much time we have for these.
Thank you, Kim, and thank you, Kenny. Thank you, Raghu. I think we're running out of time. A number of questions have been handled through the Q&A feature. For those that have not been answered yet, we will follow up after the webinar. Remember that you will receive a note with the link to the replay, as well as the resources Kenny mentioned during this webinar. And don't forget that next week we will have the third and last part of this webinar series. We will talk about how Red Hat and Hortonworks help extract value from the data lake. And with that, I want to thank you all, the attendees and the speaker, for today's call. And we will speak to you hopefully next week during our next webinar. Thank you. Goodbye.